This tutorial will cover the structural data and generated loads tables in the results. The story information is accessed by the following: go to table, structural data, and then story information. The story elevation, floor and ceiling depth, wall height for the foundation, ceiling, as well as for every other levels of the structure are presented. The following figure shows a typical multiple story light frame wood structure along with the associated shear walls assumptions to the right. Also seen in the story information table is the length subjected to shrinkage, which is used to determine the hold-down deflection component of the four-term deflection equation found in the Special Design Provisions for Wind and Seismic, also commonly referred to as SPDWIS. The length subjected to shrinkage can be entered for individual floors in the following column of the structure input form by selecting the structure icon. The equation used to determine the length subjected to shrinkage can be found in the Hold Downs tab in the Design Settings under the Wood Properties and Construction Details. The 0.925 factor default value is explained by the fact that it corresponds to a nominal 10-inch floor joist, and when combined with 3/4 inch flooring material, it yields a 10-inch factory default floor depth seen in the floor and ceiling depth input in the structure input form view. This value can be adjusted by the user and will be reflected in the structure input form view. Let's say we change the value to 0.938. It will automatically change the value in the structure input form. The extra 4.5 inch added to this amount is the typical value resulting from typical construction of multiple wood light frame structures, as they generally use 2 top plates and 1 bottom plate. If this is not the case in the structure the user is modeling, it is possible to change the value. The change will be reflected in the structure input form. If one floor is different from the others, it can manually be changed in the structure input form. The length subjected to shrinkage for one level is shown in more details here. As you can see, the bottom plate of the upper story, along with the joist depth and the 2 top plates of the lower story, are considered in the length subjected to shrinkage. Also shown is the joist factor. The joist factor is obtained by dividing the nominal size of the joist by the joist size. Now going back to the original settings, the anchor bolt length is used to calculate the additional elongation when it is not included in the displacement, or for the additional elongation for the portion of that anchor bolt in excess of the maximum bolt length for published displacement. The anchor bolt length is found in this column and is also found in the results. The resulting displacement can be found in the hold down displacement table for flexible or rigid, wind or seismic load cases under the following column. The formula used is the following, where P is the strength level uplift force, L is the bolt length entered in the structure input form, minus the maximum bolt length for a given displacement from the hold down database. A is the bolt cross-sectional area, and finally E is the steel modulus. The block and roof information is accessed by the following: go to table, structural data, and then block and roof information. The block information presents the Cartesian coordinates of the main blocks as well as the location of the ridges of each block and their respective elevation. The roof information is found beside the block information, and it describes the type of roof, its slope, and overhangs on all four faces. The dimensions of the blocks, height of walls, depth of floor joists, foundation elevation, number of levels, and anchor bolt length are determined by the user by accessing the action menu and then blocks, or simply by selecting the structure icon in the toolbar. Note that once the walls of the structure have been extended, it will no longer be possible to modify the number of levels. The roof input information is accessed by the action menu and then roof, or through the roofs icon in the toolbar. Here, the size of the roof, type, flat, gable, hip, or joint, ridge direction, slope angles, ridge elevation, overhangs, whether the corners are joined or not, can all be specified by the user in the roof input form. The sheathing materials by wall group can be accessed by the following: go to table, structural data, sheathing and framing materials. This section presents the different sheathing material combinations used throughout the structure. A group is described by its two surfaces, exterior and interior, followed by the material used for the surfaces. A legend is also included at the bottom of the table with a description of the terms used in the table. The table is divided into two sections, one focusing on the properties of the sheathing and the other on the properties of the fasteners. In order to describe the sheathing adequately, from left to right are the rating of the sheathing, the thickness, the gypsum underlay if any, the number of ply, the orientation of the sheathing, and finally the shear stiffness obtained from the following tables. The fasteners are described by the following properties: size of fastener, the type of fastener, whether or not it is a deformed nail with increased withdrawal capacity in a yes or no answer format, the edge and field spacing of the fastener, and finally whether the sheathing is nailed to blocking at all panels in a yes or no answer format. The framing material by wall group is obtained by scrolling down the table of sheathing materials by wall group, as it is located just below the legend. Here, the table indicates the different framing materials by wall group by specifying the species, the grade, width, and depth of member, the spacing center to center, the specific gravity, and the modulus of elasticity. These two tables show some of the most important results, as they have most of the shear wall construction requirements that should be incorporated in a typical shear wall schedule. A multitude of sheathing combination or wall groups in the design results is not practical. Therefore, a good strategy is to limit the unknowns in the design in order to reduce the number of wall groups. Furthermore, using the feature of design and group for walls that are expected to have the same configurations will also reduce the different wall groups. The properties of a wall or groups of wall can be changed using the wall icon in the toolbar. We will choose the exterior walls to be exterior segmented walls for both levels, while we will leave the interior wall as interior segmented. In addition to designing the walls in groups, It is also helpful to use the worst case rigid versus flexible diaphragm in the design settings. For more information on the worst case rigid versus flexible diaphragm option, please refer to Tutorial 3 Design Settings. We will now rerun the design. As expected, there are less wall groups, which leaves less room for error on the construction site.